Okay. Yesterday we completed basically the discussion about volumes and flow rates. Okay. So, and then we discussed about a factor which you need to incorporate in the design to accommodate for the variation within the hour. And what did we call that factor? The peak hour factor. Okay. So, let us take the discussion forward. Now keep in mind, we are discussing which type of parameters? Macroscopic. Okay. MACRO. Macro. Okay. The second macroscopic parameter that we will discuss is speed and travel time. Okay. And we all know what speed is, right? No, yesterday everybody was saying, oh, we know what radius is. So what is speed? Distance upon time, right? Okay, thank God. So whenever we discuss speed, you will see in most of the cases it is related to travel time. Even in the coming chapters, when we will discuss the chapter of speed studies, it is with travel time. Okay, because they are linked. Speed goes higher, travel time less. And less is like this. No. Okay. Now we are talking about speed as macroscopic. So we are not talking about the speed of single vehicles or individual vehicles. We are talking about average speeds. There are two ways to calculate average speeds. Okay. There are two ways in which you can calculate average speeds. We call them time mean speed and space mean speed. Okay, time mean speed and space mean speed. Not there. Okay, so now you can read the definitions, they are almost the same. Okay. Mean speed of vehicles passing over a point or lane of the highway over a specific time period. Space mean speed of the vehicles occupying a given section or lane of the highway over a given time period. What's the difference? What's the difference between them? Yeah. So in the first one, we are calculating the speed of the vehicle as they are passing a point. Okay, or a lane. In the second one, we are interested in a section, not a point. Okay, so the method of taking the speed is different in both of them. In the first one, you take the speed of the vehicles as they are passing a point. So then you need some equipment, some measuring device which can measure the speed. You cannot do it manually, right? Science has not progressed that much. So you can just see a vehicle and tell me this is the speed of the vehicle. Okay. So we need some radar, some sensor to measure the speed because we need the speed of the vehicle which is passing over a point. And the second one, we are interested in the speed of the vehicles over a section. Now this becomes easier. The section has a length. So you can see how much time the vehicle is taking to pass the section. And then you do distance upon time, like you said. The second one, you can do it easily even with the stopwatch. And the first one, then you need some sort of radar or sensor. In terms of their calculation, these are the equations. So TMS, so D upon T is what? The speed of one vehicle, right? D upon T is what? Speed of one vehicle. Okay. Divided by N, which is the number of vehicles for which you found the speed. Okay. So D upon T upon N. And then in the second one, you can see D is constant. We are taking the summation of what? Or taking the average of what? The time. Summation of T upon N will give you what? Average time, right? Okay. So in the first one, you are taking the average of speed direct. D upon T is what? Speed. So summation of D upon T upon N, average speed. In the second one, you are taking distance, which is the distance of the section, divided by the average of time. Summation of t upon n is what? Average of time. Okay. So this is the main difference between them. In the TMS, time and speed, the distance and time for each vehicle can be different. But in the second one, SMS, space mean speed, the distance is fixed, which is the section itself. Okay, and you are just observing the time. Now, what did I say about TMS earlier? That it should be the speed of the vehicles which are passing a specific point. Then how did the distance come from? Why do we have the distance? For a point, the distance is 0. Okay, so 0 upon time, everything is 0. Happy life. It's not like this. In many cases, you don't have a radar or a sensor. Okay. So they are giving us flexibility in terms of calculations that you can even do TMS by distance upon time. Okay. Even for TMS, you can use distance upon time. But we will discuss later on, there is a limit. When you are taking TMS using distance upon time, then there is a limit for the distance. Okay. So for SMS, space mean speed, distance is the entire section. For TMS, distance is something smaller. Okay, we will discuss the limits later on. Clear? Okay. So d upon t, in the case where you don't have the radar or the sensor, you have to take distance upon time. You can still do it, but you can see the equation is still different. Okay, and they will give you different answers. These two equations with the same data will give different answers. Okay, let us see how. 6 vehicles, distance 1000 feet. For each vehicle, the travel time is given, which they took to cover this much distance. Okay, you will calculate SMS and TMS for the same data. Okay, now for TMS, I should calculate first what? TMS. What should I calculate first? Speed for each vehicle, right? For each vehicle, I should do d upon t. Okay. Give me the values. Keep on forgetting that I'm recording. Okay. So it was 55.5, then 50, then you said 45.4. Okay, next. 52.6. Next is 50 and 50, right? Okay, now you can give me TMS, just take the average of these values. Okay, how much is that? Simple average. $50.6. All of them are in feet per second. Okay, For SMS, the distance is 1000. And then I need the denominator, which is basically the average of travel time, right? The average of the third column. How much is it? Okay, then SMS is simply the distance upon this value. How much is it? Any questions? Yeah? No problem, right? Simple calculations. Now you can see we use the same data, same distance, same travel time, but we used it in two different equations. In both the equations, we were calculating what? Average speed. Okay, but there's a small difference between them still. This small difference is not by chance, it is usually there. And since you used, only 6 vehicles, so the difference is very small. If you use maybe 20 vehicles or 30 vehicles, same data, the difference may be larger. Okay? So, even if you use distance upon time, SMS and TMS will not be exactly the same. They are close enough. You can see they are close. If you are getting one value as 55 point something and the other value is 45 point something, then there is a mistake. Okay, but they are not exactly same as well. They are not very different, but they are not exactly same. Okay, and the difference is because of the equations themselves. These equations produce different answers even with the same values. Okay, now which value is higher? TMS. TMS is always supposed to be higher than SMS. Later on, in the field studies chapter, you will see that we use TMS. Okay, for something which requires high speed. Okay, so TMS by default is higher than SMS. Why? Because in TMS, the effect of slow-moving vehicles is less. Because of the equation, the effect of slow-moving vehicles is less. In SMS, the effect of the travel time is more. Okay? Because of the form of the equation, the effect of travel time is more on SMS as compared to TMS. And this is the reason why SMS is always lower as compared to TMS. Clear? Okay, now this is what they have found through observations. Okay, so you can see it here as well. Now, for calculations related to traffic flow, we mainly use SMS. If we are doing any calculations related to traffic flow, then we use SMS. If I ask you to calculate density or volume or flow rate using some equation, in that equation we will use what? SMS. Okay, so TMS has a very limited use, which I will tell you later on. Okay, the third macroscopic parameter is density. Now, how do we define density? How do we define density of a material? Mass over volume, right? So, how do we adopt this definition for traffic? Our mass is the cars, the vehicles. Our volume or the space is the road. Volume is the space, right? Okay. So this is basically number of vehicles over a length of the road. Okay, and that length is usually measured in kilometers or miles. It is vehicles per mile or vehicles per kilometer. Okay, so number of vehicles per unit length. And the length is kilometers or miles. You cannot measure in meters or feet because in 1 meter, in 1 feet, you will not have anything. Again, the science has not progressed that much that you can fit a vehicle within 1 meter. It will be wonderful then, but you have to be smaller as well. So, this is how we define density. If I ask you to measure density, how do you measure it?
By the number of cars with the area.
Length.
The
Which number of cars?
in one lane.
In 1 lane, when? At what time? Peak hour. Okay. Do the cars remain on the road throughout the peak hour? They are moving, right? Huh? How do you count that? Huh? You can take a photo.
You take average.
Sorry?
Average.
As the length of, yes, we can do that. But that will work if the lane is full. We can do this as well. Okay. Any other ideas? These are correct. What they are saying is correct. Any other ideas? The problem is, but you should, even if you don't have any ideas, you should understand that measuring density is not simple. You cannot just count number of cars and divide by the length, because those are the number of cars which are moving. You need the number of cars which are in that length, present. Get my point? Okay. So if you say, I counted cars for 15 minutes, you did that, right? For the dump project, you counted cars for 15 minutes, and you said there were 100 cars. Were these 100 cars occupying the road at the same time? No. So if you do, for example, 200 in 15 minutes, divide by the length, this is wrong. Because those 200 were not on the road at the same time. Yeah? So, one thing is, you can take a picture from an elevated point, picture by a camera, picture by a satellite, okay, and you can then count how many cars are in the picture, because they are now at that time. When the photo was taken, these are the number of cars which were on the road. This is one thing. Other thing is, you know the length of the section and you know length of one car. You divide the entire length with length of one car, so you will know how many cars can be on the road. If the lane is full, obviously, the lane will not remain full always. Okay, so this can be one of the methods. But now you can imagine at least this much, that measuring density is not simple. It's not simple counting cars and divide by the length. Clear? So you need some calculations, okay, or some other type of equipment that can give you the density. Simple counting will not work. Everybody agreed on this? Okay. So density most of the times is calculated. So we use some calculations, some other parameters which we can observe easily, like speed and volume. You already did, right? You counted cars in your term project, vehicles, and you measured speed. So these things are easy. Yeah? Even you guys can do it. Okay. So it's easy. So we can calculate density using these. One method is this, or you use a satellite image, a camera, some other equipment. I will tell you there's another equipment by which you can measure the speed. But then you use some equipments or sensors to measure the density. Okay. So there are two ways. You can calculate density, or you can measure it using an equipment. That equipment may include a satellite or a camera. Okay. Now, why density is important? In terms of traffic flow on a highway, density is considered as the most important parameter, not flow and not speed. If somebody asks you how is the flow on the highway, that will depend upon the density. How is the quality of flow on the highway? That will mainly depend upon density. Why? There are three reasons which are mentioned here, but you can think about other points as well. First of all, density is directly affected by demand. if there is more demand for the highway, demand meaning more drivers are on the highway, then the density will be higher. More people on the highway, right? So they will be closer to each other. Less space between them, the density will be higher. So high density gives you an idea about demand. High or low density gives you an idea about what is the demand of the highway. Secondly, it affects the selection of speed, which you can also imagine as well. If density is higher, your speed will be low. Why? Less distance between the cars. You are closely packed together, so you cannot afford to go at high speed. Okay, and vice versa. If density is low, speed can be high. And speed affects flow. High speed means flow will be more. Okay, so you see density is affecting speed as well as flow. Okay, and yeah, it also gives you an idea about something which you cannot measure. That is comfort of the driver and the freedom to maneuver, freedom to do his actions. Okay, when density is higher, comfort and freedom will be less. Less space, right? Okay, and vice versa. Density is higher, density is lower, then you feel more comfortable and you have more space to accelerate and decelerate and change the lane and change the direction. Yeah? You can see density is affecting many things, or density is indicating many things. The comfort of the driver, the freedom to maneuver, the speed, the flow, the demand. Okay, that's why for a highway, it is considered as the most important parameter. Okay, when we measure the performance of the highway, we use density. Yeah. Okay, now we will discuss microscopic parameters. But before I move on to that, we discuss how many macroscopic parameters? Huh? 3. Which? Volume, speed, density. Flow and flow rate is part of volume. Some types of volume, right? And microscopic parameters we will discuss 2. Okay. The third one, there is a third one as well, which we will not discuss. What was that? They showed you earlier as well. Speed. Huh? Which is speed? SMS, TMS, which one? Average. SMS and TMS both are averages. Individual. When you take the speed of one vehicle, that becomes a microscopic parameter. And you all know that. Okay, so there is no calculation in that. Okay, so we will, but just keep in mind the speed of each vehicle is considered as microscopic. Okay, we'll start with spacing. The spacing is the distance between two vehicles, consecutive vehicles, okay, which are next to each other or which are in pair, and the distance is measured from a common point for both vehicles. Okay, common point can be, for example, you start measuring the distance from the front bumper. So the spacing will be till the front bumper of the next vehicle. Clear? Okay. When you go for driving test or the driving lessons, they will ask you to keep what? Huh? A clear distance, right? Between you and the other vehicle. Okay. So this is the only time when they put their phone aside and they will tell you keep a distance. They're only afraid about that. Okay, so is that distance the spacing? The distance which they are trying to tell you that you should keep this much distance. Is that distance can be called as spacing?
No.
No? Why not?
Because the common both
Yeah. Yeah. The distance which they are referring to, which normally we refer to as the clear distance. Okay. That distance is not called as spacing. It is good for the understanding of the driver because the driver knows how much clear distance he can see. Okay. But for traffic flow analysis, we use spacing, which is from the common point. So it includes the length of the vehicle as well. So you see this one. This is the clear distance. And spacing is, so if you start measuring from here, it will be till this point. So you see the length of the vehicle is part of the spacing. Clear? So spacing includes the length of the vehicle. If somebody comes and says, I will measure from the rear bumper, then it will be till the rear bumper. Okay, so the length of the vehicle is still included. Somebody says, I will measure from the tires, it will be till the tires. Clear? Okay, so it's not the clear distance, it's basically the distance from the same reference point. Okay, and it includes the length of the vehicle. Okay. Now, so spacing between different pairs of vehicles will be different, right? You measure between the first pair, second pair, third pair. Every pair may give you a different value. So let's say you have 100 values. Okay, and you take the average. The average is, let's say, 150 feet or 200 feet. So that means what? On average, after every 200 feet, I have a car or a vehicle, right? Okay. So this is 200 feet per car, 200 feet per vehicle. And if you take the inverse of that, it will become what? Vehicle per distance, right? 200 feet is distance, right? Vehicle per distance. And what did we call vehicles per distance? Density. Okay. So dA is the average of spacing, and if you take the inverse of dA, it will give you density. Capital D is density. So like I mentioned, for density we do some calculations. This is one of them. One of the methods of calculating density is what? Use average spacing. But it has to be average. You cannot take a single value and do the inverse and tell me this is density. This will be wrong. Okay? So you need number of values. For those values, you will take the average. That will be dA, and then you will calculate density. Clear? Okay? So it should have been D equals 1 upon dA, right? Inverse of dA, 1 upon dA, right? So what is 5280? To convert, because the spacing is supposed to be in feet between two cars or between two vehicles. The distance is very small. But for density, you cannot measure per feet, as I mentioned earlier. There is no car which can fit in one feet. Okay, so it has to be in miles. Okay, so this is the conversion for feet to miles. Okay, and similarly, I think, yeah, this is the equation for meters. So density is in what? Per meters to mile. Per density. The unit of density is vehicles per distance is what? Mile in meters. Kilometer. Kilometer. You see, keep the same units. So if you measure the spacing in meters, you will measure density in kilometers, vehicles per kilometer. If you measure the spacing in feet, the density will be in vehicles per mile. Yeah? Okay? Somebody just found the magic answer. That when from here onwards, I think it will start. Whenever I am asking about units, somebody will add per mile and give me the answer. Okay, and that will always be wrong. Okay, if vehicles per mile is wrong, then vehicles per mile per lane is also wrong. Okay, just adding per lane will not make your answer correct. Okay, so this one vehicles per kilometer, this one vehicles per mile. Here it is in feet, here it is in meters. Okay. Second microscopic parameter, headway. Headway is the time difference between two vehicles to pass a point measured with a common reference. Okay, the time difference between two consecutive vehicles which are passing a point measured for a common reference. Okay, so spacing was distance, right, between two vehicles. This is time. Okay, so you can see now there are two vehicles. This is my point. So headway will be after the first vehicle passes, how much time the second vehicle will take to pass the same point. Okay, this will be headway. So when the first, okay, so when the first vehicle passes, you will start your stopwatch and you will end it when the same point of the next vehicle reaches the observation point. Clear? Again, it is for the common reference. So we started the time when the front bumper passed. You will stop the time when the front bumper of the next vehicle comes. You started the time. The most common thing is we start when the wheels have passed, because these are easier to see when they pass the point. So if somebody started the watch when the wheels have passed, so he will end the watch when the wheels of the second car have come. Okay, so again, common reference. Yeah. Now, so headway will be in, what are the units of headway? Seconds, right? Okay. And again, between each pair of vehicles, you will have different number of seconds. So these are two cars, and two others will come, and two others will keep on coming. Each time you will get a new value. Okay, and then you can take an average of all the values. Okay, and this will be, for example, this value is, let's say, 4 seconds. So the average headway is 4 seconds. So this tells you what? After every 4 seconds, there's a vehicle. So 4 seconds per vehicle, right? 4 seconds per vehicle. If I take the inverse, it becomes vehicles per second or vehicles per unit time, right? And vehicle per unit time is what? Headway. Vehicle per unit time. The flow rate. Vehicles per hour, vehicles per 15 minutes. This was all time, right? In general, we flow rate. Okay. So if you take the inverse of average headway again, it will give you flow rate. It will give you flow rate. There. So you can see here, V is a flow rate, small v. Small v is always a flow rate. And HA is the average headway. HA is the average headway. So again, it should have been V equals to 1 upon HA, right? The 3600 is, now it's the conversion from seconds to hours, because the flow rate has to be in hours, right? Okay, cannot be in seconds. But the headway is in seconds. Between two vehicles, we cannot have hours, right? So this is a conversion. Okay. Which units? Meters or feet? Meters or feet?
No unit. Barely.
No distance, right? It doesn't matter. It doesn't matter. Okay. But again, it cannot be one headway. It has to be average. We'll take multiple values, we'll take an average, and that will be used here. Clear? Okay. Why are we calling it flow rate? I already converted to per hour. The value is vehicles per hour. Why am I calling it flow rate? Why not volume? Yeah, it could be less than an hour, but we are calculating. We are not sure about the observation period. For volume, the observation period must be 1 hour or more. Okay. In this case, usually it's less than 1 hour, but even if it is more than 1 hour, we are not sure. Okay, so we call it flow rate. Now we use. So now we have completed macroscopic and microscopic parameters both. Okay. The use of macroscopic parameter, volume, speed, the average speed and density, will be more in this course. Okay, you will see that we are using it in all the chapters: density and volume and average speed. Microscopic parameters are not used that much in traffic flow analysis. Okay, what is the use of microscopic parameters? One use I already showed you, which was what? If I give you microscopic parameter, you can do what? If I give you spacing, you can do what with it? You can calculate density, right? If I give you headway, you can calculate flow rate. So with microscopic parameters, you can calculate the other side. Okay, so maybe you are not interested in microscopic parameters. You want macroscopic, but the values you have is microscopic. You don't have that much time to get the volume and the density and so on. You can just take some spacing and headway values and you can calculate the other parameters. Okay, this is one use. Another use is which you will not look at, but it is already included. You remember I showed you some graphs about how the speed of the trucks goes down when you are on the slope, on the gradient. So for those graphs, they must have studied the trucks only, right? Okay. In some cases, we study only the cars. In some cases, we only study the bikes and so on. So in those studies which are focused upon a specific type of vehicle or a specific type of driver, then in those studies, microscopic parameters are more helpful. Because how the vehicle is moving or how the driver is behaving, it shows in the headway and spacing. If the driver is aggressive, headway spacing will be less and vice versa. Okay? So one use of microscopic parameter is to calculate the other parameters. The other use is to study the behavior of specific types of vehicles or specific types of drivers. We did one study in which we studied the behavior of the driver when they are distracted, when they are talking, when they are using the phone, okay, and then we used the headway and spacing. Okay, so something like this. I want to see if the driver is busy, what is happening with his driving behavior. Okay, so instead of we use speed again for each driver, and then we use headway and spacing as well. So another equation by which you can calculate a macroscopic parameter using a microscopic parameter. Okay, so HA is what? Average headway, and DA is what? Average spacing. Now spacing is distance, right? Distance between two cars or two vehicles. Okay, and headway is time between two vehicles. So distance between two vehicles, time between two vehicles. Distance upon time. Okay. Now since you are using average values, so this is also average speed. But we said two types of average speeds, right? Time mean speed, space mean speed. Which one is this? Space mean speed. Okay. This is space mean speed. Clear? This one is space mean speed. Why it is space mean speed we will discuss later on, but from this equation just keep in mind that this is the one which you are calculating like this is space mean speed. And what is this now? 1.47, we have used it earlier. 1.47, it was the side distance equation. 1.47.
No.
We use it in the stopping side distance equation. It is not a stopping side distance. Yeah. Yeah. From because this is in feet, this is in seconds, and the speed should be in miles per hour. Okay. So this is that conversion. Okay. And if this is in meters and this is in seconds, then the speed should be in kilometer per hour. So this is the conversion for that. Okay. Okay, let us use some of these equations which we have seen. Congested multi-lane highway is going to have average spacing 200 feet, average headway 3.8 seconds. Okay, so spacing and headway is given. Rate of flow, density, and speed. Okay, so they have given me two microscopic parameters and they're asking me for all the macroscopic parameters. Okay, so let us start with So average spacing is 200. If you have average spacing, you can calculate density, right? Give me density. Okay, average headway 3.8 seconds. Rate of flow. Seven, 8, 9. Sure. Can someone else confirm? 3600 upon 3.8. Okay, and speed 200 upon basically this one 0.68 into 200 upon 3.8. Okay, the units of density. What are the units of density? Huh? Vehicles per mile, yeah, and per lane as well, yeah. Units of flow rate. Flow rate, huh? Vehicles per hour per lane. Why we are putting per lane here, I will tell you now. Okay, but for per lane, we did not do any calculations. It's like a default. Okay, and what about the speed? Miles per hour, right? Okay, first of all, we did not do any division by the number of lanes, right? Did they tell you how many lanes there are? No. Okay, so why I'm putting per lane? Because you used headway and spacing to calculate it. Now, if I ask you to measure the headway between two vehicles, they should be in the same lane. Huh? You cannot measure headway or spacing between two vehicles which are going in different lanes because they are going together. Okay, it doesn't make any sense. Okay, so when you use headway and spacing to calculate these things, they automatically become per lane. Now, what about speed? Should speed be per lane? No. Okay, because if I tell you I have 26.4 vehicles in one lane. How many vehicles in two lane? You will multiply by 2, right? And it will be a different number, 50 something. But if I ask you, speed in one lane is 35, so speed in two lanes will be 70. We're saying yes. No, right? One car is going at 35 miles per hour from this lane. If it comes to this lane, it will also go at the same speed. So speed is never per lane. Okay. Flow rate and density can be per lane because if you give me for 3 lanes or 4 lanes, the values will be higher, right? They will be multiplied because this is count of vehicles. So vehicle count will increase with the number of lanes. By speed, this lane or this lane or this lane, it's the same. Clear? Okay, so speed is never per lane. And whenever you use headway spacing for calculating density and flow rate, it will be by default per lane. Okay. This is another question which is related to the same equations. Okay, so they have given you what? Headway, and they have given you speed, and they are asking you for density and rate of flow. You can calculate the values yourself, but tell me what you will do. How will you calculate density?
Spacing
You have to find a spacing, right? And how do I find out a spacing?
from equation for speed.
From equation of speed. Speed is given, headway is given, spacing is unknown. Using the equation of speed, you will find out spacing. Using spacing, you will find out density. Okay. And what else? Rate of flow? Easy. You have headway, you can find out rate of flow. Okay. You can do it yourself. Okay. If you want to confirm the answer, you can let me know later on. Okay. Thank you.